So hi everyone. Today we'll be discussing about how to create a game using Pygame library in Python and reinforcement learning, especially Q learning. So using Q learning and Pygame, we will try to develop a Python game. So let's first of all understand the environment, what we are trying to create, what game we are trying to create, and then later on the Python codes to understand how it has been created. So if you are able to see this particular image, this is one of the images from the game that I'm trying to create, that is Traffic Turbo. So here at the top left corner you can see that there is a person who's standing here, and there is a home at the bottom right corner. Now there are certain signals, road traffic, certain boosts present all over the route, and the idea is to reach to the home in the least number of steps. So we'll try to train a reinforcement learning agent for that, and let's see how it is able to reach out to its home. So basically in this environment, if you can see, traffic and traffic signal and multiple cars shows traffic. So basically this will be penalized. So if the hero goes to his home through this paths, if it is on traffic lights or on these cars, he'll be getting negatively rewarded. But if he comes on these boost signals, these green signals, then he'll be getting positively rewarded. And once he reaches his home, the episode ends and the player wins. So let's try to train a reinforcement learning for agent for that, and let's see whether he is able to reach to his home or not. So basically, I've already trained this reinforcement this agent, as you can see. So I'll be telling you how I've created this whole thing, where you can see the footsteps starting from some random points. Basically, this is a training part that I'm trying to show you, where we have trained the agent using Q learning, and we're trying to figure out the value function at each and every state. So each and every cell in on this particular map can be taken as a state. Here you can see that when starting from zero, how the agent after being trained is able to reach to his home. So if the user is on road, he is getting rewarded negatively -3. If he's on boost, the green boost signal, he's getting rewarded 0. Traffic signal is -20. Car jam is -50. Reaching house is 500. Already visited a cell is -10, and invalid move is -100. So basically, if the user is again going on back to the path on which he has already visited in that particular episode, he'd be negatively rewarded. And an invalid move means like a user going out of the map. So for example, if he's at the corner of the road and then he takes a left where there is no road existing, the reward would be -100. So you can see that here all the rewards are negative except reaching home and the boost reward. So basically what we're trying to do is to maximize the value function, and in the end of the day we'll be choosing the function which has the maximum value. So here you can see that negative rewards are basically punishment that are being given to agent so that he doesn't take those steps at those particular states. That is the whole concept of giving a negative reward in a reinforcement learning agent. So using Pygame window, I will be animating the whole thing, and I will be incorporating reinforcement learning within that. So let's get started. First of all, I will be importing Pygame and initiating the Pygame environment. Then display surf variable will help us to set up the whole window, the game window that you saw, and we will be drawing all the pictures, all the images over that only. So the game window is of the dimension 500 cross 500. And I've also used an agent called as pygame.time.clock. So the clock objects helps us in maintaining the idle speed of transition on Pygame window. So when we would be animating stuff, as you saw, the footprints getting printed, so it will helping us in maintaining the speed for all the transitions that are happening. Before we move ahead, we need to know a few things about Pygame also. So pygame.event.get function helps us to trace any event that is happening on the Pygame window. So like it can be the case, the user is clicking, the user wish to quit the window. So all these events get traced. All these events are getting captured by pygame.event.get. Clock.tick.1 helps us to maintain an animation window of 1 frame per second. Pygame.display.update, whenever you draw any object on Pygame window, you need to update the display so that it is visible to the user now. And display.blit function helps us to draw any object on the Pygame window. So for example, you wish to draw a rectangle, so you will passing a rectangle and comma the top left coordinates of that rectangle where you wish to draw it on the Pygame window. So let's get started. I will be showing you how I have using all these functions. So first of all, we will be importing all the required libraries and initiating the basic variables that we require. So the first variable is qtable that we have initiated with all values 0. Qtable will help us to save the value function for each and every state pair that is present. So for each, so we have 100 states. That is the window that we saw early in the video was of the dimension 10 cross 10, 10 rows and 10 columns. And 4 by 4 it means that at any state we can have four options, four actions to be taken: left, right, up and down. That is why the table is of dimension 100 cross 4. Then there is a reward map. Reward map is basically to map a given entity on the map, like traffic, road, there was a house, jam, and their associated rewards. So I will be directly using this reward map. Direction is basically a dictionary for mapping string names for the actions to an integer. Alpha, beta are basically used in the q learning formula. Greedy and random is basically used for maintaining the trade-off between explore and exploitation in the epsilon greedy policy that we would be following. So I think before moving on with this Pygame approach, you need to know basics of reinforcement learning. If you don't, do visit my previous videos for that. Delta is basically mentioned for the, so for the change the epsilon and greedy trade-off from time to time. So there would come a time where we would stop exploring and move on with the greedy approach only as our agents start converging to results. Then there is a text space that is mentioned 150, so it is not much of a significant use. So when you saw the video, there was an certain meta information that was going around. So here you can see that episode number, state, action, reward. So this text space is basically for that. Start state is 0 and state is 99. This is because, as I told you, the dimension of the window that we are on which we would be playing is 10 cross 10, that is 10 rows and 10 columns. Cell dimension, this is interesting because for each of the icon that we're displaying, the road, the traffic signal, etc., we need to occupy it in such a way that we form 10 rows and 10 columns. So cell dimension is based on that. So game dimension divided by total number of rows that we wish to have. So game dimension is 500. If you remember, we made a display window earlier of the dimension 500 cross 500. So cell dimension is 500 divided by total number of rows, that is 10. Final coordinates is basically the coordinates of the home, that call the left, the bottom right corner you saw in the window game, in the game window where a house was made. The so final dot chord basically represent the coordinates for that particular window. Game grid is basically the Pygame window we are talking about, in which we will be pasting up some icons that you saw. That it is called as game grid. Uh, Apart from that, there is an action space that we have declared. So action space is nothing but how the coordinates will change depending upon the actions. For example, if I explain you one of them, when action is 0, the x coordinate is minus the cell dimension and y coordinates remain 0. So basically it represents the left direction to be taken. So action take left is represented by 0. So in that case, what you will be doing, you will be reducing your x coordinate by the cell dimension, and the y coordinates remains unchanged. So if you see here, one cell dimension represents one icon. So if I'm here and I take a left, so this means that I would be moving from this point to this point. This means that I would be subtracting one cell dimension to reach to this point, and in y coordinates there wouldn't be any changes. So that is what getting represented there. Apart from that, I'm also if this is basically for as training may take some time. So this is basically saving the queue table and game grid. Here you can see self dot queue table, self dot game grid, nothing else. Now, the next function that we're declaring is print summary. So print summary is nothing but the values that you saw, episode number, the state action that are being taken, the text space. Majorly, we'll be using print summary for that. So print summary has been done using setting up a font using pygame.font.font. We have set up a size, and on the text surface, we are rendering the text that has been passed, and then we are building this text box using display.blit function, as I told you earlier. Now, initializing the game environment first of all. So what we are trying to do here is we are trying to paste up the icons, traffic image, jam image, fast image, road.png, all these pngs on the game grid. So using this function, what I'm trying to do here is in the numpy array, the game grid array that we had, which is full of values. So it just has values for now. but for displaying on Pygame window, I need to replace these values by images. So basically, I'm trying to map images name with values in this game grid matrix now. Now using this image loader and initial state function, I would be drawing that game grid on the Pygame window using display surf. So here you can see that display surf.fill 000 means that we are starting with a blank image, completely nothing on the Pygame window, and then one by one reading, we will be reading the game grid. We will be reading the cells of the game grid is nothing but an n cross n array. Now this n cross n array consists of image names for each value, which image to be drawn. So we are loading this image using cell.image which is a function declared here. This function is basically loading images using pygame.image.load, transforming them and returning them. And then we are deciding over the coordinate over which this image has to be built out. Now once this is done, we are building out this image using display.blit function again. So coordinates have been calculated, the image object has been returned by image.loader, image underscore loader, and eventually we are drawing this particular image on the on the specific cell. Now like this, we will be going through the whole game grid, and we will be plotting out images throughout the Pygame window. So we are just initializing the environment for now. Now this function is basically to draw footsteps. So you while training, you saw that there were certain footsteps that can build. So it is again nothing but the same. We would be considering a PNG file which consists of a picture of feet. I will be transforming, loading using pygame.image, and then building it using display.blit function. Now this is very important. This is basically mapping of states to state to coordinate, and coordinate to state. So basically, in the mathematical terms, the state of the agent would be changing, but to show on the Pygame window, we need to provide it with some coordinates. 500 cross 650, the dimension of the game window. 650 is because 150 extra in the height, because 150 is occupied by the text space, if you remember. So how we are calculating the state for your imagination purpose? States will start from this point: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. In this way, I have imagined the states, and eventually this mathematical functions will help us to calculate the state given the coordinates. The first coordinate is basically the x coordinate, and the second coordinate is basically the y coordinate. So in y coordinate, we will be first subtracting the dimension of the text underscore space 150 apart, and then we will be multiplying the total number of rows, plus we will be considering the x coordinate divided the cell dot dimension. So in this coordinate state calculation function, what we are doing is that we're trying to calculate the state from the coordinates given, and in the next function we are trying to calculate the coordinate from the state given. As the window size for the Pygame is 500 comma 650, and cell dimension is 50 cross 50, so assume that we have coordinates 400 and 500, 400 comma 500. Now we will be using this particular function to calculate the state. So coordinate one, that is 500, 400 comma 500. So the second element in the list, 500 minus cell dot text space, that is 150. That means 350 divided by cell dimension, that is 50, that is 7. 7 into rows, 10 rows, 70, plus 400 divided by cell dimension, that is 58. So 70 plus 8, 78. This is the state that we got. So given the coordinates 400 comma 500, the state is 78. Similarly, reversing the whole logic, you would be able to get from the cell from the state, you are able to calculate the coordinates. So this is done because the reinforcement learning environment is working in terms of mathematics, in terms of numpy array, but the Pygame environment requires updates in the window. So the coordinates are being calculated to update the Pygame window, and nothing else. So if your state is assumed at 78, we will be reversing the same example. So 78 mod self dot rows is 10, hence giving you an 8 into cell dimension. Cell dimension is 50. 8 into 50 gives us 400, comma state is 78, division self dot rows, that is 10. So it would be 7 into cell dimension into self dot cell dimension, that is 50, giving you 350, because 7 into 50 equals 350, plus self dot text space, that is 150, giving you 500. Hence the coordinates become 400 comma 500. Hence this is the whole mapping that is done. So 400 comma 500 fed into this function gives you 78. 78 fed into this function gives you 400 comma 500. This is the whole mathematics. The next function helps us to check the validity of the move. So if the move is already visited, if the coordinates are already visited, or if the coordinates are within the Pygame window, so it should not be the case that the new coordinates calculated are are going outside the Pygame window. So for example, if you look at this particular window, assume you are at this particular point, just follow my cursor, and you take a down action. That means there is nothing. This action is going outside the window. This would be an invalid move. Now this is the most important part that we are coming to, updating the Q table. So first of all, using the state, we will be calculating the current coordinates, and take considering the action, we will be calculating the new coordinates also. So the current coordinates are calculated. We have the action. So using the action, we are calculating the new coordinates also. Now the new states is on the new state, depending upon the new coordinates is calculated, and then we are checking whether the new state is valid or not. And depending upon the validity of the new state that we are getting, we are calculating the reward function, and we are returning multiple things, that is whether the move is valid or invalid, what is the new state, what is the new coordinate after taking the action, and what is the reward. So reward is getting set up depending upon whether the move is valid or invalid, and depending upon the reward map that we decided earlier. So if so depending upon the force state, whether the move is invalid, whether the cells are already visited, whether the cell is boost, whether the cell is traffic signal, or whether the cell is home, depending upon that, reward will be calculated using dot self dot reward underscore map dictionary. Now once this is done, if you remember, q learning is basically an off policy reinforcement temporal difference learning method. If you have, if you don't know it, you can visit my previous video on q learning. So basically in this we would be for calculating the future reward from the next state, we would be using greedy approach. So here you can see that for the new state in the q table, we are trying to calculate the maximum amount. Maximum amount means a greedy approach, that which action is giving you the maximum amount, minus self dot q underscore table. So the current value function, we are subtracting the maximum reward that we can get from the future state, minus the current value function, calculating the state value difference, and then updating the q table value function for the current state using this particular equation. Self dot q table state action equals to self dot q table state action plus alpha into reward plus beta is a discount factor, if you remember from our previous video, into self state underscore value underscore difference, which is getting calculated here. So basically we are following epsilon greedy approach for the, calculating actions for the current state, and greedy approach for calculating the action for the next state. That is, it is called as a q learning method, which is called as an off policy learning, because we are following different policies for both current and future states. Now, once this is done, this is the particular formula that we are following for writing the Q table. Now, for each episode, what we are trying to accumulate all the functions that we have described earlier in this particular video. We are trying to aggregate everything. So, in this particular episode, first of all, we will be calling on pygame.event.get. We will be calculating the coordinates for the current state, and then put that coordinate into already visited state. Now I would be visualizing the steps, or this particular coordinate that has been selected using steps dot visualizer. So the steps you saw in the training video were using this particular thing. Now until and unless the current state is not the end state, or whether it is and it is valid, there would be a loop that would be running through, in which what we would be doing is we would be going for a random choice, true or false, giving weights, self dot greedy, self dot random. So if you remember, we set up self dot greedy as zero point 0.4 and self dot random as zero point 0.6. So this is the epsilon greedy approach now that we are coming to for the current state. Now if the choice is first choice, that is true, then we are going for a greedy approach, else we are selecting the action randomly. Once this is done, we are sending this to update the Q table for the current state that we already discussed about, using that state value difference that we are calculating, updating the Q table value. If the action is invalid, if the is valid flag is false, and the coordinate is not an already visited coordinates, this means that the move has made the agent to move out of the map. Hence, it is an invalid move. Else, it is the cell might be already visited. Now all the drawings that we have made, we would be updating the pygame window, so that everything that has been written on the pygame window gets updated. We have set a clock tick for zero point 0.9, so making the animation a bit faster. We'll be appending the coordinates the new coordinator are getting pretty visited list. So you can see the summary for the whole explanation that I give you right now. Now, how to train this particular agent? We have done everything now. We will initializing the initial state, printing the required logs, again setting up various display. Now, for epoch, after every 50 epochs, what we are trying to do here is we are trying to increase the greedy approach by 0.005, the delta we have set up earlier, and random we will be trying to reduce by 0.005, because we are, as the training progresses, we wish the agent to move towards greedy approach rather than the random approach. Hence, we will gradually turning an epsilon greedy approach into a completely greedy approach. Now, this will be running for some multiple epochs. Once this would be done, we will be testing out this particular environment by setting the initial state as 0. So while training, what we are doing is that we are not setting any initial state, and we would be starting from any random state. So as you say on the training, also the footstep are coming from any point. This is because we wish to train on all the states at any point. So it can be the case that if we start from just the zeroth state, so the as we move away from the zeroth state, like for example 70th or 79th state, the model might not be able to train properly, as it might not get enough chances. That is why we would be initializing every time with a random state while training the whole loop. While testing, we'll be setting up grid equals to 1 and random equals to 0. And we'll be saving the queue table and game grid also. And initializing the state, we will be setting up the episode with initial state equals to 0. And then you should be able to train your agent like this.